Hi, welcome to MTE 241. I'm your course instructor, Andrew Morton, and we're sitting here looking at the Learn site for our course. So let's go to the content, and you'll see there that the course syllabus is posted. I'm going to go through that first. Then if you look on the left side here, we've got lectures. Under lectures, I've got the video lectures posted. Problem sets, I've started posting some there. Tests are empty right now. I'll be posting those as we go. The labs, the lab instructor has already added a bunch of stuff for you to look at. So let's take a look at the syllabus. So here's the syllabus. The course name, which I always have trouble remembering, is Introduction to Computer Structures and Real-Time Systems. So it's a little bit about how computers are put together, how you do I/O, and also real-time programming. So you can see my contact info there. Don't come by my office, I won't be there, haha. And there's Bernie Roll's information. He's the lab instructor. We've been working together on this course since spring of 17, and he's been doing it even longer than that. We have two teaching assistants. They're both veterans with the course as well. The calendar description says it covers computer organization, so that's like, processor, memory, I/O, basic real-time concepts, process management, inter-process communication, synchronization, memory management, resource management, interrupt handling, concurrent programming, file systems. We're doing all of that except the file systems. We can't really practice that with the lab setup that we have, but I cover some socket programming, which is very useful, and a few other things that aren't listed there. The text for the course is free. It's written by Douglas Harder, so he taught it a couple of years before I did. He's a lecturer in ECE like myself, and he wrote this 500 or 600 page textbook after doing it once, and he never got assigned to teach it again, so that's something. Okay, course organization. The lectures are going to be pre-recorded. You can watch them at any time. I'm trying to work about 3 weeks ahead for those that wish to get working ahead. Tutorials will be pre-recorded, as are the lab instructions. We will have office hours, so you can have that kind of face-to-face interaction via WebEx or Zoom, platforms like that, depending on the TA, lab instructor, myself. I'll probably use WebEx. And for those, you'll just email us and ask for a time, and we'll make that happen. We're going to be using Piazza for question and answer for this course, for the labs, for the lectures, for problem sets, tests, for everything. And feel free to post answers to questions and help your classmates. Just don't give them the answers to the tests. Okay, so there's a lab 0, which has no weight. It's just how to get set up, and then there are 4 labs, each with a weight of 8%. There are 4 tests. They have a weight of 12% each. These are going to be 36-hour take-home tests, and they're at the end of each quarter of the course after every 3 weeks. And then during the final assessment period, as they're calling it these days, there's going to be a summative assessment. So I'll release that pretty early, around August 1st, and it will be due at the end of that assessment period, which I think is August 15th. Yep, there's the dates right below there for the deliverables, so you can see the tests and the lab demos. So you're expected to work on the lab demos. You'll have 2 weeks to do it. You can get help through Piazza or by making an appointment with the TAs or lab instructor, and then there's one demo day, but there's 3 people available to demo, and there's a bunch of 15 or 20-minute slots. You need to sign up for one that works for you and your lab partner. Okay, let's keep going. So I'll talk first about the lectures and stuff, because that's what I know best. So if you go to the Learn homepage for this course, as we were just there. Go to content, lectures, and under there's videos, and I've divided those up into topics, which are listed below. So you watch those videos, and the way that I traditionally teach this course is that I write notes. I used to do it on the Blackboard, but then had back issues, and so then I've been doing them with the document camera, which has actually been nice. My notes are better that way, and seems to have worked well. I'm doing something similar here, so it's going to be kind of Khan Academy style, where I'm going to talk, I'm going to write notes, which you will see as I talk while I'm writing on a tablet, and I expect you to actually make your own notes. It's a good way to learn actually by writing stuff down. You remember it a lot better than if you just like watch something going by or just listen to it. Yeah, so watch the videos, record your own notes, and then there will be problem sets to help you practice some of the concepts, followed by a test. So I posted these on Learn. You can download those if you want to watch them, when you don't have internet access or for whatever reason. And I'm also uploading them to YouTube. I'm actually uploading them to YouTube first and then downloading them, because YouTube has this great proprietary compression algorithm, so the videos are about a fifth of the size after they've been compressed, and then I upload them to Learn. So it's identical content. Choose what you like. So we got 4 quarters in the term, 3 weeks each. And so you watch the lectures, and then you do the problem sets. And the problem sets, if there's a couple for that quarter, you don't have to wait till the end of the quarter. You can get started on them once you cover the topic that's the subject of the problem set. Tutorials will be pre-recorded and posted a week before the tests, and the TAs, myself, will monitor questions on Piazza, and again will be available for help via live online conversations, meetings. Okay, so the tests, they're going to be 36 hours. I'm thinking, my plan is to release them 8 in the morning on Thursday and have them do 8 p.m. the next day, Friday. So you got 36 hours to do whenever works for you. Some people like to work early in the day, some people like to work late. And yeah, the tests are definitely individual work. Do not discuss the test with anyone else. You can post questions for clarification on Piazza, that's fine, but yeah, don't talk to other people. If I was in a meeting with a bunch of associate chairs the other day. I'm the associate chair of ECE, and I heard from the associate dean that they're really cracking down on cases of academic misconduct that do get detected. It's harder in this environment, but if somebody cheats on an exam, they're getting I think expelled is not the word I want, but kicked out for a term. There's a different word for that. Anyway, yeah, so for these tests, they're going to be a mix of written answer, so kind of like, a pen and paper test. You'll scan those, take a photo with your phone, whatever, type them on your computer if you must, and upload them to CrowdMark, and so the TAs and maybe myself will mark those. And there will also be some programming questions that you will upload your code, your C files, to a Learn Dropbox, and I will actually download those and compile them, and the marks will be based on the test cases that I run them through and how well they do. So Alison Gianni-Kuris, I have trouble with her last name. Anyway, she may have taught you your digital circuits course last term, and she will be teaching your ECE 325 computer interfacing course in 3A. She's always getting after me. You gotta get them doing more programming, so I'm doing that this term. So if you don't like it, tell Allison next term. So for the tests, basically you got 36 hours. so there's no grace days or anything like that. Get it in on time. If anything comes up, email me. But don't leave it to the last minute, especially the programming questions. You never know how long they'll take. Okay, so the first quarter. There is an introduction. It's just a couple of pages. Oh yeah, so my videos are basically one video per page, and they range anywhere from about 2.5 minutes to 16 minutes. So there's, I think there's 2 videos for the introduction, and then we get into computer structures, or I call it computer hardware here. So how memory works, SRAM versus DRAM, talk about hard disk drives, solid state drives, not so much. And some content that I added a couple terms ago was caching and virtual memory. So those students that do go and do systems programming type co-ops, and there are a number of you in that category, benefit from knowing that kind of thing. So I've added that. We'll talk about MCUs, which are microcontroller units. And then we'll, after we've done that, introduce the hardware a bit. We'll talk about C programming. It's just, I know you've done C++, so I'm not going to teach programming all over again, but just the things that are a bit different that you need to know about. So structs, which are like classes without methods. Unions, which look similar to structs, but they're different. And the C preprocessor, how compiling works, how your program starts, and how your program is loaded into memory, what goes where. So there are 2 problem sets, one for the computer hardware component, the other for the C programming component. And those are already posted, so feel free to go knock them off right now. The solutions are also there. Work on the problem set before you look at the solution. It's the best way to learn. Get stuck and then look, or don't get stuck and just solve it. I don't know. And then the test is scheduled for Thursday. So that's the end of week 3. So May 28th, 8 a.m. to May 29th, 8 p.m. The second quarter of the course covers memory mapped I/O, how you talk to I/O device interfaces, and polling I/O and interrupts, and how to write interrupt service routines, that kind of stuff. And once we've done that, so that's about probably a week and a half, no, about just over a week's worth of material. And then the scheduling is a longer section. It's about 2 weeks worth of material. So we're going to talk about what's a real-time operating system, how do you use it, what is concurrent execution, which really is kind of like parallel, but concurrent doesn't guarantee that things are operating at the same time. They can be interleaved, they can be sharing the same time processor in these little units of time called time slices. And we'll talk about some scheduling algorithms, timeline scheduling, fixed priority preemptive, and earliest deadline first. 3 of the most common ones out there. There'll be 2 more problem sets, PS3 and PS4, not posted yet, but they will be within about 3 weeks as soon as I get those lectures posted. So I got the first quarter all done and posted. Second quarter is yet to happen. And then there's a test, so that's the end of week 6. Third quarter covers static and dynamic memory allocation. That's very short, it's about 3 pages. It's basically how does malloc work, when should you or shouldn't you use it in a real-time system, and how do you not use it if you're creating objects. And then we're going to get into the real part of the course, synchronization. So when you've got tasks that are running concurrently, essentially in parallel, how do you coordinate things between them or synchronize things? So there's these basic primitives, synchronization primitives, like the semaphore. Semaphores are basically flags from the old sailing days. Mutexes, mutual exclusion, barriers, and then we'll talk about applications of those and interesting problems. So I'm going to expand your mind. There should just be 1 problem set for that section, but it'll be a pretty good size one. Then the test for that will be at the end of week 9. The fourth quarter covers communication. So the producer-consumer problem, bounded buffers, which is basically how you communicate data between tasks in a real-time operating system. And then we'll get into a bit of queuing theory. It's kind of fun, it's different, it's basically applied stats, but it's useful for I guess parameterizing an application or getting a feel for how big your queues need to be or your buffers need to be, that kind of stuff. And then we'll wrap up with a bit of fault tolerance, distributed clock synchronization, and then time permitting, we'll talk a bit about network programming. It's not covered anywhere else in your curriculum, and if you're a systems programmer, you're definitely going to encounter it. So we'll talk about TCP/IP, which is the network model that the internet is based on, and how you program it, which is socket programming. So there's probably going to be 2 problem sets there, 6 and 7, with a test at the end of week 12. Now moving into territory which I am familiar with, but I'm not as involved in the day-to-day with it. So we're using the Kyle Microvision IDE, and so it's an integrated development environment. You're writing programs in C, and they're going to run on an LPC 1768. It's a microcontroller which has an ARM processor in it. You're writing in C, so you don't really need to worry about ARM assembly language. You don't need to at all. And it also, along with the processor, packages a couple of memories and a bunch of peripherals, timers, I/O devices, and such. And because we're all online this term, we're going to be simulating execution on an LPC 1768, which is mounted on the Kyle MCB 1700 development board, which adds some LEDs and switches and a joystick and that kind of stuff. Okay, so there's labs 0 to 4. Lab 0 is just getting set up, and you should do that in the first week. In fact, I would encourage you to be working on lab 1 in the first week, if at all possible. So yeah, lab 0, just you write a hello world program, but there's a bunch of steps involved. So and then there's 4 real labs for marks with a weight of 8% each. So the first lab 1, you're learning how to use the debugger, debugging a program that's given to you. Lab 2, you're learning how to write values to these magic memory addresses and making lights turn on and stuff like that, and reading inputs. And then in lab 3, you're going to build on lab 2, and you're going to have multiple tasks or threads of execution running concurrently and doing stuff. So that's when the fun stuff happens. And then lab 4 is buffering. So we're going to apply a bit of the queuing theory, the client-server systems, and buffering that I mentioned before. So labs are done in groups of 2. You can pick your lab partner from anyone that's registered in the course. We're not really worried about lab sections this term. Same with tutorials. So source code in this course is typically due before you demo. I'm assuming that's the case this term. And late submissions are 25% penalty per day. You can talk about these projects or these labs with other groups if you need to, but try to solve things as much as you can within your group, and definitely don't share code. That's a good way to get in trouble and have a chat with the associate dean. Yeah, so one more note, the software that we're using, this integrated development environment, it's built to run under Windows. We have provided support for Mac and Linux users. I saw the computing survey results, and there's one person in the class with said they've got a Linux machine, but they also have a Mac machine. So the Mac users can use VirtualBox. It's free. It's escaping me right now who developed it. Oracle. Oracle did. So they used to be a database company. They branched out. Anyway, so they provide VirtualBox. I believe it's open source. It's free, and it allows you to install a Windows VM, which you can also get for free, and the instructions are provided on Learn. There's also Mac has the Parallels hypervisor or virtual machine. That's another way to do it. It's not free. I believe it's adware and possibly limited in how much you can do with it, but I haven't used it. I've got an iPad. I do not have a Mac, so it's not supported because we don't have a way to test things. Okay, so for the lab, Bernie's posted all his lab videos. What you should do is go to the course homepage, go into content, go to labs, and right at the top is lab notes. Read those. Right now, just lab 0 is visible, but he'll be opening up labs 1, 2, 3, and 4 as we go along. And I'm sure if you ask him nicely, if you want to see the next lab and it's not opened up yet, that he will do that for you. The summative assignment, this is going to be instead of a final exam, so it'll be in the final assessment period, I think they're calling it now, and it's going to be individual, and you're going to be writing a concurrent program that runs with the real-time OS that we're using in the lab and in the course. And so it should be a challenging assignment. It's worth 20%, and it will be due at the end of that assessment period. And so that will make Allison happy, and it will also give you some good solid experience doing real-time programming. And learning objectives. These are here because I'm told they have to be, but I'm not going to go through them. I think we've covered what we need. And the policies, you've seen these before, so that's all that I have to say about that. So let's go back to the table of contents, and I'll show you the lectures. So there's 3 parts. There's videos, lecture program code, and lecture handouts. I will refer to the program code and the handouts in my lectures. You don't need to look at them yet. We look at the first lecture handout in the 3rd topic of the 1st quarter. And you can see that I've grouped the videos by the topic. So the introduction, let me just go into the introduction section. It's just got 2 videos. There they are. If you like, you can download them, or you can click on it to go to the video. Okay, problem sets. You can see problem set 1 is there, solutions are there, problem set 2 and solutions. The tests are not revealed yet because they're not supposed to be, but they will be revealed at these times here. And finally, here's the lab section, so read those lab notes. There's a demo schedule that you can sign up for with your lab partner, and lots of stuff there. The VirtualBox instructions for Mac users. And finally, there's an old test section. I wouldn't even bother looking at it. The old midterms and final exams really aren't relevant this term because everything is open book this term, so it's going to be completely different, and I think it would be a waste of time. You're better served by watching the videos, recording notes, doing the problem sets, and that should prepare you for the tests. I believe that's all that I've got to say for now. Go ahead and start watching lectures, taking notes, and working on problem sets, and have a good term.